Okay, sir. A very, a very good afternoon to everyone. My name is Parva Bagdai. On behalf of the Petroleum Dev, I welcome everyone present here. I hope you are doing well. I extend my sincere welcome to our today's speaker, Mr. Avnesh Kumar Das. The knowledge coming from the experience cannot be achieved from any textbook. With this code into our mind, Petroleum DEFS is collaboration with SkolarGate has organized a webinar on the introduction to production facility. So let me introduce to Mr. Avnesh Kumar Das, who has more than 11 years of experience in the production domain. He is currently sharing a post of Deputy Chief Production Engineer at the OIL, that is Oil India Limited, in Duliajan. Before we start, it's my humble request to every attendee to maintain the decorum of the session. And if you find any query, then drop it in the chat box with your name. Session will be open at the end for question and answers. Now I would like to hand over this session to Mr. Avnesh Kumar Das.
Thank you, sir, for introducing me to this August gathering. I'm really grateful to you all for leaving your priorities aside on a weekend afternoon and turning up for this session. I'm really grateful to Petroleum Devs and SkolarGate for providing me this platform to interact with you all. I'd like to start by wishing you and your families my personal best for your health and safety in these difficult times. Okay, so myself, Anvesh Kumar Das, currently working as Deputy Chief Production Engineer in Oil India Limited. Till now, I was mainly looking after the surface production facilities. Right now, I have been transferred to Frontier Basin Department so that we can look and develop into new ventures of Oil India Limited for the OLP blocks, etc. So my today's presentation will be mainly to provide information about the fundamentals and principles of these surface production facilities. I'll be mainly discussing with you the operational activities at the surface facilities, starting from wellhead, tubulars, and vessels, storage tanks, etc., keeping safety in mind. So our oil and gas industry is mainly divided into three segments or sectors: the upstream sector, the where the drilling of the well and production from the wellhead takes place, and the well fluid, whichever is found to be commercially viable, is processed into the production facilities and in the midstream sector, and transferred to the refineries or power plants through pipelines. So Oil India till today has mainly concentrated into upstream and midstream business, but in a recent development, Oil India has procured majority shares of Numaligarh Refinery Limited, so making it as a total company, like functional in all the three sectors: upstream, midstream, and downstream. So as we can see from here, that our main area of operation is in the northeast part of this country. We are mainly based in three districts of Assam: Dibrugarh, Tinsukia, and Sivsagar. So over here, we have explored almost the length and breadth of this part of the country. We have drilled more than 1,700 wells, and we are catering to almost all the companies over here, like Indian Oil and BCPL, Numaligarh Refineries Limited, NIPCO Power Plant, Assam Power Distribution, Assam Petrochemicals, BBFCL, Assam Gas Company Limited, and apart from that, to almost all the tea gardens in Dibrugarh, Tinsukia, and Sibsagar district, in Moran district. So we are present almost in the life of every Indian over here. There is a little bit of oil in everyone's life. So basically, my job starts with this diagram. Uh, this is a schematic of the well, a well in which the formation pressure is sufficient to produce the well fluid at commercial rate on its own. So initially, in the initial phases of the well, most reservoirs are having the pressure which allows the well to flow on its own from the reservoir to the well bore, and from the through the tubulars to the wellhead, and then to the production facilities where processing of the well fluid takes place, and after that to the desired customers. So if we look into the wellhead, so our in fact I forgot to tell one thing, that our job, a production engineer's job, mainly concentrates on optimizing the completion design to so that this reservoir deliverability can be achieved more, to forecast the performance of various elements comprising the production systems. Any kind of restrictions that we will look into the further slides of this presentation, that any kind of restriction or limits in the production system, and identify any means of improving the production through this. Okay, so this is a Christmas tree. This is a set of valves, spools, fittings, etc., connected at the top of the well to direct and control the well fluid, which flows from the formation to the well. So this is the upper master valve. Basically, in high pressure wells, there are two master valves, upper master valve and lower master valve. Two sets of valves are provided so that in case of one valve fails, the other valve can be operated. So this is basically an on-off valve, which either allows the flow of the well fluid to the surface, and in case the upper master valve fails, then we use the lower master valve. So this is a production wing valve, side valve. Basically, we know it, in one side it's production wing through which we take the production. Another side is kill wing valve. In case of well cooling operation, this valve is used. So in normal time, it is kept shutting. So this is a surface choke which controls the flow quantity of the well, and this is a top valve which is only used in case of any downhole operations. So in a nutshell, this is about the details of Christmas tree. So our daily job starts with checking well check operations, where we check the Christmas tree visually, and also take the pressure and of the various one, like tubing head pressure. This is the 5.5 casing pressure. Also, we take the 9.5/8 casing pressure. So we check these kind of parameters to find if there is any kind of discrepancy, so that we can address. In case doubt arises, what is the like significance, then we can see it over. This is as I have shown earlier, that as through this side valve, leakage has occurred, and this has occurred mainly due to sand ingression. So the in later stages may encounter or develop sand ingression, water cooling, etc. So when this occurs, immediately we shut down this master valve, and after that we replace or repair this side valve, and then this leakage stops. So every now day we have to monitor these wells, so for any kind of anomaly or discrepancy. Uh, as we can see over here, first I will concentrate on this wellhead, and from there I will move into the later part of the later part of the presentation, I will move into other aspects of surface facilities. So this is Naharkatia 356 back in 2010. These are the visuals from 2010. So when the well was kept shut in, almost all the wellhead fittings, actually this well has ceased to flow due to low pressure. So and it was a gas well. So when the well was kept shut in, almost all the fittings has been stolen from the wellhead. So one fine day, the pressure had developed inside the well, and it has started flowing on its own. So the blowout has occurred. So immediately, our team has moved into the site. This is a fire service team for cooling. Since this is gas and any kind of ignition or spark nearby can ignite the whole thing, and the situation may go out of hand, so immediate cooling, etc. And since this was a sunny day, even a slight increase in temperature could have been devastating for us. So cooling had started. So after a tedious effort, this master valve has been placed, and after that, this Christmas tree has been put on top of it to control this wellhead. Like that, it occurs on 17th October 2021. I received a call from the security team that on Naharkatia 329, almost all the fitting had been stolen, and the 5.5 casing side, the production casing side, the valves had been stolen, and so the well has started to flow on its own, and it has become uncontrolled flow. So by evening, the flow had gone up to more than 20 feet. So it was on the verge of another blowout. So immediately we rushed into the site, and this time it was a bit difficult since almost all the starting from the adapter flange, almost all the fitting had been stolen. So finally, at 1 a.m. in the night, these valves have been put over it, and in the casing side also. So, and the well had been brought under control. So this kind of theft of wellhead fitting is frequent over here in case of the shut-in or low pressure wells. So we had to be always all the time more careful about these wells. In some gas wells, due to retrograde condensation, very good amount of condensate are produced. So the miscreants also tampered these wellheads for pilferage of condensate. But during this may catch fire, because this is very volatile substance and hazardous in nature. So any spark or ignition near it may catch fire into it. You see, the whole wellhead fitting had been burned, and rubber seals, etc., inside had been totally damaged. So this wellhead is of no use, and the well was having at the time pressure of FTHP 165 170 kc, kilogram per square centimeter. So it has been killed using a coil tubing unit, and after that the wellhead was changed, and the well was then brought into production. You see, this is the pilferage assembly that had been attached to this choke, and that had caught fire. So to avoid these kind of conditions, we also on our own we had devised our surface protective equipment. So this is a wellhead cover to keep the well away from miscreants. But you see, even they try and were successful to break into it. So this is me inspecting into the damage that had been done. Also, in some of the wells, we have made the connection directly from the master valve so that they cannot mm, uh, mm, shut down the well and steal the this thing flow wellhead fittings. This is the production choke, and there it goes to the surface facility. Apart from these miscreant activities or well tempering remedial jobs, we also do slick line operation, coil tubing unit intervention, well stimulation, and workover jobs in our wellhead. If you look into this diagram, then you can visualize that in case of oil wells, uh, actually crude oil consists of carbon from C1 to around C80. So the higher hydrocarbons, mostly the aromatic and resins, they have this tendency to stick into the walls of this tubing or tubulars. So in case of any pressure drop, there will be immediate coagulation or sticking of these hydrocarbons like resins and aromatics that I said into the walls of this thing. To avoid this kind of situation, daily scrapping. The scrapping implies like uh, we have in our house potato pillars, etc. So it will scrap the walls of the tubing to clear the well of this kind of restrictions. Else what will happen, this restriction will finally jam the tubing. So there will be an entire restriction over there so that no amount of fluid passes through this. And on finally, when there will be an entire restriction over there, the well will cease to flow. To avoid this kind of condition, mm, we always do scrapping kind of job. First, we will look into that where this kind of solids deposition occurs. As I have said that wheresoever pressure drop occurs, like from the reservoir to the well bore and from the while going up into the surface, so there are major restrictions over there. So in case the well is of more than 2000 meters, so restriction will be more from 0 to 1000 meter, or in certain cases it's up to 1500 meters. So there will be an entire restriction which needs to be cleared. So the frequency of the cleaning job depends on the amount or the kind of carbon restrictions. So it may be daily in nature, it may be once in 2 days, 3 days, maybe bi-weekly, or maybe weekly, maybe fortnightly, like maybe monthly. So it depends on the nature of the crude. In certain cases, even scrapping won't suffice. So we'll look into that also. So this is a kind of scrapping operation visual you see. So this is a BOP, and this is a pressure restriction, so that when the well will be opened, no amount of the well fluid comes out on its own kick, etc. So as I've said that this is a pillar kind of thing. So it will peel or wax or crude deposition on the tubing uh, and clear it. So you can see it goes inside like that, and it places over it, and the whole assembly is sealed. And then using this motor winch, it will go down up to the desired depth, maybe 1000 or 1500 meter, and then the restriction is cleared by pulling up and down like that. See, this is a wax, and this is the that cutter that I was saying, pillar. This technical term is gauge cutter. So you see the how sticky the crude is. It's like a mm, rock-like substance. So it becomes inside that tubing. So it won't allow any flow through it. So this is how the whole assembly you see it is placed over there like that. In case of high pressure wells, we use cranes also to maintain safety. As I have said that in certain cases, even scrapping won't suffice. So in those cases, we remove the paraffin or this waxy crude using uh, hot well circulation using coil tubing. So coil tubing through this is light low waxy crude, and this is heated using this hot well unit up to around temperature of 60 degrees Celsius, and from there it goes into this coil tubing unit, and this coil tubing through this coil tubing goes into the well up to maybe 1,500 meters, and then into the whole depth of this. After clearing the restriction, it goes whole to the whole depth of the well, maybe up to 3,000, 4,000, whatsoever depth is over there. So it goes directly into the depth. So the main working is like ah, so the coil tubing will go inside while circulating this hot well crude, and these will dissolve the whatever restriction is over there in the tubing, and when it dissolves, it is cleared through the well fluid into and collected back either into tank placed at the wellhead or into the surface facilities nearby. So this is the main working principle. No, and in certain that was I was talking about this crude oil wells. In case of gas wells, there will be formation of hydrates, etc. In case there is, or maybe due to water, this thing, water cooling. So this will form a column of water over there, and the gas or well fluid won't be able to suffice that water column, and it will be unable to flow on its own. So uh, to help in that condition, in case of gas well, since these are very gas well is not that economical for artificial lift, etc., apart from plunger lift. So uh, we use also in remote location nitrogen pumping unit. So nitrogen has this expansion ratio of more than 1:300. So this liquid nitrogen through coil tubing goes inside, and when it expands, it generates pressure, and that is able to take out the whole water column outside the well. So using that, we can activate the gas well. So this is basically the well flow schematic from high pressure well, oil, water, and solution gas. So it will be totally mixed. This well fluid will go into the group unit 1 separator. This is basically first stage separator in our surface facilities. This depends on how you design this separator. In our case, in certain installation, it's 19. In certain installations, it's 14. So basically, it's a lot of permutation and combination. But in our company, we generally prefer to keep it like 3 or 4 stages of separation, not more than that. So first stage of separation, it will be a two-phase separation. Gas will go directly into the distribution grid or cross-country pipeline grid directly to the customer, or even we have our own gas-based LPG plant. So some of it also goes over there. The oil and water is then sent into the second stage of separation, a separator. From there, again, gas comes up. The more volatile component that evaporates as gas. It's around 2 to 2.5, and it's sent into the compressor for compressing it again to 19, it's a 14 to 19 kc pressure. A part of it goes into the distribution grid, and where the gas pressure is like gas production is low, it can also suck some amount of gas from the distribution grid in case gas lift is required. Since gas lift is very low cost in nature, so in most around 95% of our wells are on gas lift. 95% of artificial lift wells, not all the wells. 95% of artificial lift in our case is gas lift. Remaining 5% are SRP, ESP, etc. So it goes to the glycol dehydration unit, since it will be pressurized into very high pressure gas using this second stage of compression at around 90 kc. So this 90 kc, it will be reaching the wells at around 60 to 70 to 75 kc. I'll show you why. But again, for this second stage of separation, we do have feed. Apart from first stage of separation, we do have feed from low pressure self-flow wells or artificial lift wells also. So these will join the feed from first stage separation and will directly go into the second stage separation. So a typical composition of natural gas is like that. Methane will be 85 to 90% associated gas. In case of non-associated gas, it will be 90 to 95, 96, like that. Means anything over 90% of methane is non-associated gas, typically, because associated derived from gas well without any association of crude. So basically, they will be more into lower hydrocarbons like methane, etc. So from the quality also, you can decide that this will be non-associated gas. So remaining volume will be complete by this higher hydrocarbons. So you can see over there that anything over C3, C4, its percentage is low, but its quality, like hexane plus component, these qualities are more or less near this thing, like petrol, etc. So any amount of this hexane, etc., will due to adulteration in petrol, it finds a huge market. So it's a miscreant racket over here, and you can see over here that the boiling point of this thing, C4 to C5, this is around 0 to 50. So that means these gases, when pressure drop occurs, like from at atmospheric condition, like 0 to 50 is somewhere near to atmospheric condition. So this from gas will turn into liquid with a slightest drop in pressure. So as I have said that these will be in around 90 kc pressure. So any pilferage on this line will drop the pressure from 90 to 65, 70 kc. And with this slightest drop in pressure, this gas will liquefy, start liquefying. So a significant quantity of gas liquefies. So this becomes a huge market, and you see all our lines, etc., tempered for this pilferage of condensate in gas lift networks, because their pressure is readily available. So just you need to cut the line so that this pressure dissipates and the higher hydrocarbon will liquefy. See? So we have to do routine welding jobs over there. These are the visuals of what I was saying. So you see they cut the line and you see condensate starts pouring into. It becomes liquid, and the lower hydrocarbon like methane, ethane, etc. This evaporates. You see over there. And this is the condensate. You see, you can easily mix it with the petrol in the petrol pumps nearby, and you sell it on a routine price. Now the price of I think within a few days it will be touching around 120. So they will find more bigger market. You see, for cutting these lines, sometimes we has to face the burn. So you see the whole garden drains are filled with this hazardous crude oil. Even the miscreants doesn't know the difference between the gas line and oil line, so they will cut all the line, and then these drains are full of crude oil. You see, to avoid this, the for in one such case, the well fluid has been mixed with crude oil fluid so that they won't be getting any condensate from these lines. So you see, this is a non-associated gas well with flowing pressure of around 170 kc, and this was an oil well with flowing pressure of around 150 kc. So both the fluid, well fluid has been mixed using a manifold so that no amount of gas goes outside, and then this from this manifold the well fluid goes into the respective installation. So in this way the pilferage in these lines has stopped significantly. Inspection of pipelines are also necessary because in this part of the country rainfall is very heavy rainfall occurs. This is a tributary of Brahmaputra. So in rainy days, the landslide may occur, which will result the pipe to go down and cracks may happen. So this oil spillage may occur. So inspection of pipelines are also very important for us. So now coming to the installation part. So the gas, in case of it's a non-associated gas well, and there is no oil collecting station nearby, then we directly send the gas to nearby fill gas gathering station. So it's like a gas well is a high pressure well, or its normal pressure is more than 150 kc. So since it's a high pressure gas, so we provide two chokes to avoid the formation of hydrates. So this to avoid formation of hydrate, we also let the gas to pass through water bath heater, indirect water bath heater. Basically, this shell and tube heat exchanger where the well fluid passes through the tubes, and it's preheated in this shell, which is full of water and which has been heated to around 60 to 80 degrees Celsius. No, anything more than 80 degrees Celsius will let the water evaporate and expose the tube. So we keep the temperature around 60 to 80 degrees Celsius, and it preheat the tube also. So it goes into this choke, and as the After coming out of the choke, the pressure and temperature significantly drops, and again it's to avoid this after cooling. So again it's heated back, and finally the reduced pressure fluid. It's like from 150 kc to 21 kc. Then this is processed in the two-phase separator, and the gas goes to the distribution grid. Why choke? Choke, basically chokes are of two kinds. It's a variable choke where you can, it's a needle valve kind of thing. You see over there a needle. So you can adjust how much flow you want to allow, or it's a fixed choke like this. So this is basically an orifice effect like this. You can see in the pipeline. So this is the upstream of the choke. So maybe upstream pressure is around 100 kc or 80 kc. So there will be a restriction over there. So the whole volume will adjust into that restriction. And after this choke, then again it will come out and expand. So the whole volume while expanding will reduce in pressure. So there will be a certain pressure drop over there, which can be seen in this graph. So this is the upstream pressure where adjustment for the choke pressure goes up, and then again when it comes out of the choke, so there will be a drop in pressure. So this is a permanent pressure loss. So downstream pressure will be obviously less than the upstream pressure. This is basically done to avoid, as I have said, the formation of hydrates. As you can see over here, that higher hydrocarbons, when temperature drops, in summer it's everything goes perfect, but in case in winter, whensoever there is a pressure drop, we generally observe this hydrate in the line. So with any drop in pressure, like and drop in temperature, there will be definitely formation of this one. So this line signifies that curve, at what pressure and temperature this formation of hydrate, etc. ice will take place. It also depends on the composition. This is a pressure temperature one, but one of the most significant part is the composition of the gas. More the higher hydrocarbons are present in the gas, more are the chances of formation of this hydrate. You see, so this is basically like methane. So methane doesn't have that much affinity for this hydrate or hydrogen bonds. So whatsoever hydrate is formed, it dissolves with the flow. So that's not difficult. But with this one, this neohexane, cycloheptane, you see how complicated the structure becomes. So in no time, it will form a chunk of or bulk of ice. So it's so difficult to use process the gas wells without any indirect water bath heaters. Heating is an absolute or compulsory compulsion for production of the high pressure gas wells. So that water bath heater that I was saying. So this is the shell side. This is the chimney, flame arrestor. So these are the tubulars through which the well fluid comes into this. So along the shell, this is heated, and this is the choke arrangement, and there it's depressurized, and again it's sent back, and this after cooling effect has been avoided, and then this goes to the separator over there. So this is like that installation. This is basically a heating arrangement. There is a main burner over there. and this is a pilot burner. This is like our gas lighters that we use in the house. So in case the main burner goes out, so this always have a little flame like candle. So this again ignites back this. But there are always fail-safe mode in this one. In case of any without this pilot, accident may occur. So that is again a vast topic. I may explain if time permits. Latest slides. So coming on to the separator, these are the for gas wells, since amount of liquid is very low. So separation may require a greater residual retention time. So to provide this, these double barrel separators are used. These are the double barrel separators. So liquid is collected in this chamber. Also, filter separators are also used for quality, like in case of power plants, etc., for where turbines are moving. So a droplet of liquid or a drop of liquid may act like a cannonball. To avoid this, we must ensure that liquid is or a gas is full of free of liquid. So these filter separators are used. These are the filter units which needs to be replaced once in a year, or maybe depending on the differential pressure. If the amount of liquid is more, differential pressure will go down, and then we will replace these filter units. So its efficiency is around 99.98%. So that's the highest efficiency that I have seen in my whole career in any kind of separator, apart from glycol dehydration unit, but that's a process absorption unit. But if physical separation we are talking about, then filter separator is the best one. But only one thing is that it can provide you quality, not quantity. If amount of liquid is more, then the prescribed amount or the instructed amount, then liquid carryover will take place. Differential pressure will go down and liquid carryover will take place. So this will again create the chaos. You see, these are the filter units. This is how a real filter separator looks like. This photo has been clicked when on this annual filter element changing were program. So at that time, this photo was clicked. As I was saying, that back pressure and liquid loading may take place. Like this filter separator will always vouch for quality, not for quantity. Actually, it happened that in one of our well, water running started, and then in no time this filter separator got damaged. This filter units, and this liquid got carried over to the power plant. And you see that part. What I was saying, this turbine blades totally damaged due to this centrifugal force of water drop mb square by r, as we have read in physics, school physics. So this is the practical example of this. This whole blade has been damaged. So actually, it happened that the water cooling has started from one well, and this our separator, instead of separating it into gas and liquid, this since the liquid amount was more, so it got carried over to the gas feed. So it carried over, this liquid carried over to the power plant. So immediately, no time, this separator that in a redundant installation were transferred and placed in the installation, and this whole unit became operational to avoid this kind of thing. So now I'll be talking about the oil collecting station. Same as I have shown in the gas one. So it's like high pressure manifold through indirect heater for preheating. It will be going to the first stage of separation, and from there gas will be going to the high pressure mist separator to avoid any kind of liquid amount that may be present over there. And finally the liquid free gas goes to the distribution network. From group unit 1, liquid goes to the group unit 2, where it's joined by the low pressure wells like artificial lift wells, etc. And from group unit 2, it goes to the heater treater. Basically, it's a three-phase separator. So from three-phase separator, the gas goes to the low pressure mist separator. From there to the low pressure compressors. The liquid goes to the stabilizer, where it will be stabilized for the atmospheric pressure, since it will be going to the storage tank, and any amount of gas or like low pressure gas, dissolved gas, etc., present in this liquid may create pressure while in staying in the storage tank, atmospheric tank. So that's why the stabilizer is needed. And from emulsion treater, water goes into the that disposal water, like water goes for disposal. So it goes to the formation water storage tank that will be disposed using water disposal wells. So a slight amount of oil may be dissolved into it, emulsion may form. So de-oiler is injected over there. And here also oil soluble demulsifier is also injected to break the emulsion between water and oil. So this is the thing, and the whatsoever dissolved gas is over there in the stabilizer final stage of separation. So this gas goes to the flare. This is a technical flare, a nominal amount, just to save this tank. So this is how our field installation looks like. Oil collecting station, stages of separators over there. These are the stage 1, stage 2, stage 3, like that. These are the mist separators. Vertical, because gas, mostly gas doesn't require that much retention time, so they are vertical in nature. In these shades there are emulsion treaters. This goes like this. So basically this is a two-phase separator. So this is the inlet device, this is the foam breaker, and this is the mist through this gas comes out. So this is the wet plate for this thing, and there are baffles also. Most of these are for providing restrictions, like this whole well fluid will be coming with some pressure. So this inlet device, there will be like a bit of restriction to the momentum of this fluid, and when there will be deflection or momentum break, immediately due to the difference of density, water and or the liquid will separate from the gas. So gas will start evaporating from this, or the more volatile component, that is the gas, will come out and vaporize, and the low volatile component will remain dissolved in this one liquid stream, like that. So you see over there, it will go like that. So these separators are basically physical separators using these pressure controllers for back pressure, or in certain cases there will be liquid level controllers also. Basically these work on the difference of pressure, like you set the outlet pressure, so it will adjust itself with the controller. I'm moving a bit fast so that I can cover it with the time. liquid level controller, it works same like our washroom flush. So whensoever this is the float, whensoever the liquid level goes up, so the float will go up and this will send a signal to the controller, and this will exert the pressure on the diaphragm of the actuator. So this will open the valve, so the liquid part goes out. It's somewhat like this. There will be a float inside. So when the liquid goes up, so this lever will go down and it will generate the pressure on a control valve, and this will open the valve. So the liquid will be allowed to go outside of this separator, and again the level will drop. It's somewhat like that. So after the separator, we will cover the heater treaters. In heater treater, basically heat and chemicals are used to break the emulsion, oil water emulsion. Oil water emulsion are very difficult to break. Like there will be oil inside water, or in certain cases water inside the oil, or in certain cases oil inside the water, and inside of that oil there will be water droplets, or vice versa, or maybe there will be continuous aqueous phase. So you can imagine from or visualize from that one how difficult it is to break. So it requires heating of this thing, so that based on their boiling points or etc., they are separated. Since water is having a high boiling point as compared to crude, so and also the injection of chemicals etc. uh, fastens the process. So it's somewhat like this. So it's again a shell and tube heat exchanger. The only difference is that it will be in two segments or chambers. In the first chamber, the fire tube, the fire will be flowing through the tube. And in the shell side, the whole vessel will be full of this thing, well fluid or liquid. So its capacity is around 9,000 kiloliter per day, depending on the production. It can handle up to the volume of 9,000 kiloliter per day. So this is the inlet. So as the tube are very hot, so it warms the well fluid. So based on the boiling point, the gas goes up, and it goes through this gas chamber, and from the gas outlet control valve, it goes to the low pressure mist separators. In the liquid phase, by the injection of chemicals, this emulsion is also broken, and based on that, like we have always seen that since the oil is having low density, so it will float in the water surface. So this is the clean oil going up, and it's collected over there, and so clean oil goes towards the stabilizer before going to the tank, and water goes to the this thing, formation water disposal. You can see over here on a routine inspection, it has been found that the control valves are not working properly, water dump valve, as we say. Immediately maintenance was full of dirt. Seeing that, the heater treater was immediately advised for sand cleaning job. You can see the amount of sand. Since this is a pressure drop is not like outlet pressure is very low. After that, there is a tank only. So sand generally uh, tends to settle in this emulsion treater or tank. So you can see the amount of sand. This sand has damaged the whole fire tube. You see the chunks of sand due to presence of chemical and heat, it has consolidated into a rock-like structure. Seeing this, immediately replacement of fire tube has been advised. You can see we were saved from a huge catastrophe. If this damaged part would have touched the upper or top part, this one, then this would have caused a spark, and immediately this whole unit of around 9,000 KLPD would have exploded, and it would be like would have the capacity to wipe away a whole town. So that was the severity of that would have been the severity of this incident. So it was replaced on a very right time, correct time. After that also the sand couldn't have sand couldn't be cleaned inside the treater, so we maintained we have to allow one of our personnel to go inside and scavenge the whole thing, clear the whole thing manually. So we took all the precautions since he was going inside a closed vessel and after that cleaning occurred. So coming on to the crude oil storage tank, in Oil India, we are generally using both kind of crude oil storage tank, floating roof for high capacity installation, like our tank farms, etc. Sorry, so that no amount of liquid evaporates and causing bleed to occur. So in our tank farms, etc., or like higher capacity installation, we are using floating roof storage tank. But for our field installations, we are generally using fixed roof storage tank. But fixed roof storage tank also has this disadvantage that I was saying, that pressure. This would have occurred in like pressure. If you see over there, so if the pressure goes inside, so it may start like if any amount of dissolved gas goes inside, it may start exerting pressure on the walls or in the corners of this tank. So this would make any time like bloating effect kind of thing. This may damage or reduce the life of this tank. Also, in case of any vacuum, like when the pump starts operational, pump is operational, then this may cause the tanks to squeeze like thing. Vacuum is created. So this again reduces the life of this tank, this wall of the tank. Since this is a very big structure, around in normal field installation, it's around 760 kiloliter or per tank on this structure. So to avoid this kind of thing, we use a breather valve. So this is the normal position of the breather valve, normal pressure, atmospheric pressure, everything okay. In case the gas starts coming in through the fluid, processed fluid, then gas can above the set pressure, like in our tanks, since we are maintaining atmospheric pressure, so anything above 11 to 12 psi, so it will this valve will open. Pressure relief position. It's like SRB kind of thing. Like in our house, we are using pressure cookers. So the same thing, and this will open and this will go out. So this is like that. In case there is negative pressure vacuum, like I have said that while pumping, so it will take vacuum relief thing, like from atmosphere, it will take absorb the gas and that will go inside. So this valve becomes operational. So it's around after anything below 0.5 psi. So this valve is operational. Here again, I will show you one example of tank foundation inspection. During routine inspection, it has been found that there is leakage from the delivery line of this crude oil storage tank. So the bolts have been tightened. Still, it has been seen that the thing there is bit liquid spillage from there. So after that, it has been inspected uh, and found that the foundations had cracked like anything. See, though this tank has tilted to one end, if you can see it from there, so immediately this whole usage of this whole tank has been stopped. So you can see it over from here that how difficult is to maintain everything and how important is to observe all the routine parameters in the installations. Even in construction of these tanks also, sometimes this may happen. You see, this is a formation water disposal tank construction was going on in my side, and it has been found that the tank has tilted to one end. You see over there. So this repair job required using of these jacks. So these are all vacuum mounted jacks. So the whole tank has been lifted. See how difficult it is to conduct this kind of operation. See the whole person, 2 3 laborers are going below this tank, and any slippage or any disruption of operation would have caused them to succumb. There is no way out. There is nothing apart from these jacks. So that's why factor of safety has been maintained, where only 2 3 jacks would have sufficed. We had kept more than 6 jacks. So after that, these piles, this one has been provided below to this tank to keep support over there. And these have been welded to the bottom plate of this one. Then debris, this all the debris. Then again, the foundation has been constructed back. And finally, the tank is ready. So these operations require a bit uh, safety has to be considered while doing this kind of operation. And these are all once in a lifetime operations. So you see how difficult it is to run show in this oil and gas business. See, if we start investing in any field or thing back in 2017, then it will give us profit from 2023 kind of thing when everything will break even. So at least 6 to 7 years, a constant investment is required. So that is the thing. So what I would like to say in this kind of operation, we need to be a bit careful while dealing. I move bit fast with this presentation just to be on time. I think I completed my presentation. And now I'm ready to take questions. In case of any questions, you can please let me know. Hello.
Thank you, sir. Now, as per you, the session is open for Q&A.